Last week, we had Curtis Gallioni from Confluent's Advanced Technology Group talking about the nexus of Flink plus Kafka, and he and I had such a good time that it didn't fit into one episode. So this week is part 2. We'll pick up right where we left off last week. Let's jump in now to Curtis and Flink and Kafka. It's, and this is, I think, more a rumination than a question.
Sure.
But it strikes me that I know that's a hard problem to say, no, actually we're going to keep the whole thing around and make it queryable in lots of arbitrary ways. I mean, you're a database then. I mean, that's the one way to optimize for that problem is you become Pinot, Apache Pinot, if you're thinking about the analytic ends of things. But the more on kind of the OLAP sense of like, what's the current state of this evolving entity? I've got orders coming in a stream processor and I have to do some things to them. And I want to know what my order ID 24601, give me that JSON serialization of that thing. I've just been wondering, like, why has Flink not gone there? Is that it's so outside its mission? Definitely hard, but there's a contained version of that seems like you could just crush some use cases.
Yeah, I think it's an interesting point, and it's a good question. I think right now what it does is it makes a nice little pairing between systems that are good at that, like Pinot, and
right.
systems that don't do it, like Flink, right? So
right.
Flink is not really the thing to be serving your highly concurrent queries against right now, right? But it is the thing, and this is again why I think like the pairing, the Flink and Kafka pairing is really nice, is that it lets sort of Kafka do its thing. When you put them together, it's letting Kafka do its thing, which is I will get you data in and data out extremely quickly. I will give you very high write throughput and very high read throughput to wherever it wants to go. And so Flink can say, well, that's fine. So you'll be the state. You'll be the permanent state, persistent store. Kafka, you'll be that storage layer for me. I'll do some computation on whatever is stored there, and then I'll put it back on you. And then Kafka says, great, I'll get it out the door extremely quickly. I'll get it into Pinot, and then I'll serve up a query extremely quickly, right? So in theory, yeah, if Flink could do it all, right? Well, if Flink could do what Pinot did, then we wouldn't have Pinot. So,
and to be clear, I'm not saying, hey, Flink should do what Pinot does. And what I mean is, to do what Pinot does is actually very hard. And I can definitely understand why Flink doesn't want to be this complete other kind of thing that sort of takes a career and a lifetime to be good at. I get that, but there's a more minimal use case of, like you could do in KSQLDB, you can do pull queries on a table. So yes. I can do a key lookup on the table transformation of a stream or output of an aggregation or something. And this is, I'm sort of asking this question into the world and to the listeners. And this is a thing to think about. I'm not so much like, come on, tell me why. Tell me, Curtis, why?
What is the answer?
Why doesn't this product be the thing that I would like? I'm just thinking the simple use case of those key lookups like KSQLDB does, or like interactive queries on a Kafka Streams K table. Like, just give me a little bit of that state store. And I know it changes some things fundamentally, and maybe one day, I don't know, but that's just a thing I've been thinking about.
Yeah, I mean, it is funny. I'm not going to answer it directly, particularly, but I have had that conversation as well, naturally, right, internally at Confluent. And there are some folks who think that it should potentially expose that to us, and there are others who are like, no, what you're saying is like, that's blasphemy. That's not what it does, right? And so it's tricky, right? Because you want to have access to all the data where it is, but theoretically, I mean, there is a batch mode, right? So you could run a Flink query in batch mode, and in theory, that'll give you a pull type thing, right? A pull.
But the storage would have to. That's the thing that the sync would have to be the queryable thing. Then,
yeah,
I respect that purity of like, no, wait, it's actually real hard to be Flink. Can we just try to be Flink and not also try to be even a simple little key value database because Tim thought it was cool. And I think there's a lot of wisdom in drawing those lines. You can see over the history of Kafka how it's made decisions to keep brokers stupid.
Yeah.
And there's things that just, it would have been so easy to make the broker do that. And like, no, the broker is going to be just about useless, except for logging things and replicating them, and it's hard enough. So I think there's wisdom in that, but this thing has been on my mind for a long time. I did a bunch of episodes of the podcast last summer, just gave a talk at Kafka Summit 2 weeks ago called How to Query a Stream. And I had a Flink slide with the cute squirrel, AI generated squirrel. And I said, Flink is not a part of this conversation because it's not queryable.
I mean,
it's not, this is, if anyone hears this as any kind of deprecation of Flink, it's not that. If anything, Flink's probably wiser than I am.
I think it's also, there is a little bit of maybe like leftover terminology and leftover maybe like thinking patterns from, if you're super familiar with Kafka streams or with KSQLDB, that you expect Flink to have the same sort of access pattern.
Yes.
Whereas like you can run a select in streaming mode from Flink, like you could run, like, let's say you're running this pull query in KSQLDB, and you want to get something like that, right? In open source Flink, I mean, you can run point in time queries, right? So you can say like, give me the state of this thing at this point in time. And you can also say things like, I want to run the select, and maybe it's a streaming query, but I can fetch the results of that streaming query and paginate them or something like this, right? And so you can still go get those things. It's just not going to support, at least not right now, it's not going to support the same scale and concurrency and latency, et cetera, all the things that you probably talk about at StarTree and with Pinot.
It's
not going to support that same scale at the serving layer, right, for that. So it's not going to ever do, well, I shouldn't say it's not going to ever. Right now, you can't make it perform in that way that a specialized tool is going to perform in. It can do those things in a sort of rudimentary way, right, which is just, I'm giving you results back, and you can decide to clip them and take a little piece of them one at a time, in which case, great, I do have the results, right? Or I can get them streamed to some API where I paginate, and now I get like 10 pages of it, and now I put the whole thing together, and now I do have a full result set. But it's still running. The query is still running in the background. I think that's the fundamental difference is, in something like KSQLDB with a pull query, you expect that the query is done, and when the query is done, I'm getting no more results from whatever it was. I'm not going to call it a stream or a table, just the entity. It's like a horror movie, but the entity is no longer producing results, and therefore this query has completed, right? And you can actually put it in that like finished state. Whereas with Flink, I think the default thought model or like process model is this query is actually always running, and it will continue to produce results. You don't have to take them if you don't want to, but if you want them, you can go get them. That's fine, and you can sort of hold on to them and do things with them, whatever you want to do.
Right. Let's try the angle, in the broad kind of Flink and Kafka together kind of thing of the compute and storage framing. Now, when I talk about Pinot, I talk about compute and storage in terms of coupling, in terms of whether compute and storage resources are allocated, per query or pre-allocated. I sense that's not the framing here. But if you were to talk about Kafka and Flink as compute and storage, how would you put that?
Yeah, so that part is definitely different than how that compute storage conversation happens in Pinot. So I think there's one similarity, which is like the separation idea, right? Which is, I think, a somewhat common thread in the user-facing analytics space, is like we want to separate the compute and storage pieces, or like we want to have query processing over here and like ingest over here. Like data ingress happens in one place and query processing happens in a different place. I actually think that model does have a pretty clear analog, because again, you're saying that Kafka is streaming storage. I shouldn't say you're saying, that's what I'm saying.
One says.
One does say that Kafka is serving as that streaming storage layer, right? It is the sort of proxy file system for the database that is Flink. And again, it gets back to that like sort of leaky abstraction idea, but Kafka is not doing the computation itself. Like you actually just said conveniently, this was not pre-planned, I swear, dear listener. Um, but the brokers are dumb, right?
Mhm.
So the Kafka broker is not a smart thing. It's not really made to do some sort of computation or anything like that. It's made to move data from point A to point B, replicate it, send some acts back, and get on with it, right?
Mhm.
And it does that quite efficiently and quite nicely. But Flink is meant to, oh, I could just coin this as a tagline right now. Flink is meant to think.
There
But
you go.
oh,
All right.
we won't get into all the buzzwords of like thinking machines and
Now, okay,
all
we'll work out the prompt engineering of a squirrel with wire rim glasses
yes,
in an academic office.
exactly. Yeah, but so Flink is the thinking part of that system, right? It's not dumb. It's a place where you want to put the logic, where you want to do that computation. And so Kafka's great in that storage layer, again, like a file system is to a database.
Mhm.
Write all those results back, store them in some encoding, store them in some encoded format, um, and then pull them out when you need them, do some computation, and put them back again. But don't try to do it all in the same place, right? I think this. I don't know if this is where you wanted to go with this, but this is the other thing I would mention, I guess, is if you're trying to do your storage and your computation in the exact same place with the exact same system, um, what you're going to end up sort of doing is, well, first, I mean, from an economic point of view, you're probably going to spend more on both because you're not going to do the computation before you store it somewhere, and therefore you're going to be storing a bunch of sort of like detritus, right, and cruft that you don't necessarily need. Then you're going to do a bunch of computation on that. You're going to spend more on computation because you're doing it on data that is stored maybe that you didn't need in the first place, and then you're going to restore it again. So you're going to have all this raw data stored somewhere. You need to do a bunch of computation there. It's like my analogy for a data lake is entirely. I've stolen this from XKCD, which is brilliant. If anyone doesn't know of it by this point, I don't know where you've
Well,
been, but it's fine. Look
can't
it up.
help you. Give us a link so we can get it to the show notes for the
Yeah.
one you're talking about.
Yes. So there's a great analogy here, which is that basically people are dumping data into these data lakes. This is my take on it,
Mhm.
and then we're just walking around with this big stick of linear algebra, right? We're just stirring it up and expecting, I don't know,
To
great
conjure
results.
value.
Yes, yes. Abstract business value will actually float up from the swamp, and
Yeah.
it'll be right there for you. And you're welcome. You've punched in your different feature engineering prompts and whatever else you want. You've punched in your different values and your coefficients, and suddenly linear algebra has solved your problems. And you just applied it to a bunch of really awful looking data in a giant heap. And so that is that is maybe not that is maybe not the simplest way to do things. It's maybe not the most elegant, and it's maybe not the most cost effective. So I'm obviously
Yeah.
a partisan in this, but I don't think we need to do that much anymore.
It that sort of, put things into the cauldron and say incantations works like Act 1, Scene 1 of Macbeth, strong opening, not necessarily for data. And I'm with you there. So there's a lot to unpack here. And it's funny, when I asked that question, I wasn't necessarily even thinking of data lakes, but I see where you're going. In the case of, and this episode is about Flink and Kafka. I mean, you happen to be wearing a Pinot shirt. I'm wearing a Pinot shirt. I recorded a Pinot release video earlier today, so that's why if you're looking at the video version, you see I'm wearing a Pinot shirt, and so is Curtis. It's great, and mine is even purple, but more of a kind of a Cabernet color than a Pinot Noir color. It's always bothered me, but anyway,
It is a nice color though. I'm gonna have to get
I
myself.
love the color. Man, I love the color of this shirt. It's just not a Pinot color. So Pinot needs to own storage, and it needs in the general case, for compute and storage to be tightly coupled. The processor, as I like to say, is on the other end of a PCIe channel from the SSD, and we know everything about the file format. It's completely owned. It's not Parquet, it's not Delta Lake, it's not Iceberg. And I've had that question, like, what format's the data stored in? I'm like, well, just read the code. I don't know. It's ours. And the reason for that is because of the sort of silly non-functional requirements that Pinot is trying to satisfy of, 100,000 queries per second in the cluster and 50 milliseconds latency and petabytes of data and all that stuff. Like, you need to spend the money, right? You need to spend the money on the storage and the compute. Now, that story gets more interesting. There are tiered storage options available in the world, and things always move around from quadrant to quadrant. But back to Kafka and Flink and data lakes, you're saying there's an economic advantage in decoupling compute and storage because that means you're going to be able to make storage cheaper?
In some ways, I guess, yes. So the thing that I should make clear is, to your point, in these, and I'll use the term that you've used on the show, in your terminal database, right?
Yes.
Like a Pinot, you will eventually have to get those things back together again, right? I mean, something has to give eventually, right? And you have to serve that query very quickly. I think the key is to think about what the data is that you're running your computation over, and whether that size of that data is actually necessary. And so the reason I'm thinking about this in this way, or I'm talking about it this way, is if you use a stream processing framework, um, you're basically going to cut down the quantity of data that you have to write into some downstream place potentially, right? Because you're going to do some manipulation up front. I guess let's take the traditional example, the counterexample, which is, let's say you don't do any stream processing. You stream all this stuff through Kafka. You dump it into a data warehouse or data lake. Now, you will have some efficiencies that, obviously various technologies exist that are good at finding pieces of data with queries, whatever else.
I could Trino that.
Yes. Yeah. But maybe you didn't need all that data there, right? And so like, you're going to sort through terabytes of data to find a 5 gigabyte data set, and then you're going to pull that out. You're going to have somebody pare it down to a 1 gigabyte data set that someone then partitions out into 10 100 megabyte data sets that you then query like at a blinding light speed, right, to serve back these requests to people. That's awesome, but the only thing you actually needed was a 100 megabyte data set, right? And if so, I mean, maybe you could be generous and say, like, do the 1 gigabyte thing, partition it in the downstream thing, right? Or partition it in the terminal database. But I actually don't know which thing Pinot wants to do and what it doesn't want to do necessarily. So you can clarify me on that. That's after I sort of make this claim. Maybe I'm totally wrong. But in my head, I think, why wouldn't I pare down this data for you as a user? And then when you run these computations, or you run these, big sorts or big joins or whatever else, your intermediate result is much smaller. And so you use less compute and you store less data there in the first place.
Okay.
And you still get the results you want, and you serve them up in that terminal database potentially more quickly, because maybe the terminal database isn't actually great at joins, or isn't actually great with like weird JSON data. Maybe it really wants a really structured format, and I can format it for you so that you don't have to do all that in this downstream place.
So part of what I hear you saying is it would be a good idea to apply some discipline on write. So when you're ingesting data into the thing, the data lake house, whatever that thing is, the pitch, and this goes back, almost 15 years now, was ETL is dead. It's ELT now. So just extract and load, baby. Just put stuff in there. Just write it. It's cheap. Write more. And we'll provide frameworks for making sense of it later, and the whole schema on read thing, which I think what I hear you saying is kind of, cool story, bro, but we still need to have some discipline about what we put in there and think about the structure a little bit. Minimally, that is a claim you're making, right?
Yes, I
Okay.
think perhaps we have gone too far,
Yeah.
and I think perhaps we've allowed, and I say this as a reformed data engineer myself, we've allowed data engineers to decide that, I'm just going to go point A to point B. That's what I'm doing. I'm building you the pipe, get the
Yeah.
data there. This
Yeah.
is not my problem anymore. This is
Right.
somebody else's problem. Like,
Right.
I don't know what's in the data. I don't want to know what's in the data. They're sort of just like we're just having these couriers in the middle, and like, what are they passing downstream? Is it is it dangerous data? Have we inspected it? Is it actually even useful? Like, is there a reason to be paying to move this stuff over the network and then having it sit somewhere where no one ever touches it? Or like, should I actually pick this up, look at it, and go, oh, this is weird. It's like a blob full of all nulls. Like, I mean, that's not going to take up
Right.
much space, but like,
Right.
this is this is not actually useful. I don't need this. I'm tossing this thing. Like, this is not actually what I want. Or I have to change this. This actually isn't in the right format. Somebody sent this to me wrong, right? Instead of now downstream in some value in a table, some poor sap has to go in and say, why does this query not work? And it's like, oh, this
Right.
one value in this one field.
Yeah, this one value, if this other field has this value, it needs to map this way, and the way of things. I would, so one little bit of pushback.
Yes, please.
Yeah, because I think that's a strong point. Like, think about what you're doing. Storage is cheap. Cloud blob stores are cheap, but they're not free. They are, in fact, cash cows for the hyperscaler cloud vendors. I mean, that's
If they were that cheap, they wouldn't keep providing them, and they wouldn't have massive teams of people working on those particular object stores.
yes, and just making it so wonderful to put things in them and giving us so many great things to do. So, and not that I begrudge that being a profitable business. It's just that it's storage is not free. I mean, I have a network attached storage box at home that I back up video files to and photography things, and that backs up to a cloud service. That's not S3. It's actually a different service that the cost per byte is lower. Niche thing, whatever. S3 is not free. Let's not act like it is. So good point. But maybe where I'm going is it's hard to know. So one of the whole reasons that we kind of want to stream everything into the data lake is it's difficult to know a priori what the analytical needs are going to be. And I'm sympathetic to that.
Yeah, I hear that. Um, and generally, I would agree. And I would say I agree also because I was that person. So in one of my earlier roles, I didn't understand how the data pipeline worked. Like, I was just getting things in. I interacted with it mostly in Elasticsearch and like Postgres, and maybe sometimes I dabbled with some like Spark stuff like PySpark because I was a Python kid. I didn't know any better. I didn't know about types and all that stuff. I was like, here's a list. It has whatever I want in it. Deal.
That's amazing.
This is incredible. And somebody was like, yeah, well, what's the type of that list? And I was like, what are you talking about? It's a
What?
list. So
it's got stuff.
yeah, that was great when someone told me I had to write it down something in C, and I was like, oh, okay, I guess this is important. But
Yeah.
like, I didn't have any knowledge of the whole pipeline, right? I was just writing some analysis, and so I wasn't going to live in that pipeline world. But I think this actually gets back to a little bit. It segues back into what I was saying earlier about providing a standard in a particular tool or a particular language that me as this downstream data person was living in, and that's that SQL unification, right? I mean, Python even better, right? If you can give them Python, great, that's incredible, and you can do it all in real time. But I think of it more as a person and like skills problem than it is a like objectively we have to have this knowledge. Like, the knowledge doesn't live in the data lake. The knowledge lives in the people who use the data lake, right?
Amen.
So if the people who use that data lake actually use a stream processing system, well, then the knowledge is where the knowledge is, right? And so now the knowledge is in the stream processor, and we can sort of get that domain there. Now, can we do it for everybody? Probably not. That would be a little ambitious, right? Like at some point, somebody just knows how to use like a looker dashboard and a filter on it, and they don't actually know what the SQL underneath that's doing, and they don't know LookML, and they don't know how the SQL runner works, and they don't know that it's backed up by whatever data warehouse they use, Snowflake or something. So if they really don't know, right, if they're like truly just a like business type dashboard user, then that stuff has to stay downstream, right? Like that knowledge is always going to stay downstream, I'll say, and that understanding, that domain expertise, it will live there. For everyone who does write SQL themselves, or writes some Python script, or uses pandas, or does these types of things, I think if you put together a coherent stream processing product that, again, uses a syntax that is similar to what they were using there, I think you can get their knowledge onto the stream, I'll call it, or in the stream, or on a lazy river, perhaps, on the stream with otters like Mitch Seymour would like us have. So, something like that.
My guest today has been Curtis Gallione. Curtis, thanks for being a part of the Real-Time Analytics Podcast.
Thank you. I appreciate it. Yeah, I love being here.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.